Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3 and today we want to present Lab 5 Pelton Wheel Turbine. Our group member consists of 6 people. Siti Rahana binti Abdul Rahim, Hazika Najah binti Muhammad Kamal Arifin, Muhammad Nazirul Al-Hafiz bin Mazlan, Muhammad Afaris Afif bin Abdul Aziz, and lastly Muhammad Faris Silman bin Azmi Shah.
Assalamualaikum and very good morning to lecturer and friends. Today I want to present about the chapter 1 introduction. This is our background. Lesson in the 1870, Alan Pelton create the Pelton wheel, a water turbine with an impulse type drive. This is our demonstrate for the Pelton wheel turbine working principle. And then for our problem statement, this using an equation is possible to determine how efficient the input jet. When calculating the system total head inlet multiplied h by the system acceleration due to gravity and the distance of the liquid. And then as a consequence of modern turbine efficiency, the output power is generally expected to the lower than the input power of the number of the reason. Of the objective to determine the performance and the efficiency of the Pelton wheel turbine at the different operating conditions, to understand the Pelton turbine configuration and performance, to design a complete measurement technique of the fluid flow. For the scope, first avoid the overfilling the drum with liquid as this will allow it to splash into electronic equipment. Students must also make sure that no one around moving machine is wearing loose fitting clothes or coming into direct physical contact with them. The pump must have a constant supply of water to avoid contamination. Students must make sure that there are not visible electrical wire near the bed of the safety measure, as the tension between the bed and the drum is a fire hazard. Make sure the drum coolant area has been continuous supply of the water. Thank you for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afaras bin Abdul Aziz, MA1901. So I'm going to tell to you about the theory for Pelton lab. Okay, firstly there is water turbine. As you can see, water turbine is fluid energy is converted into mechanical work by the use of water turbine, and turbine are classified as reaction or impulse based on way in which energy is rotating blade is converted into motion. And then an increase in pressure or decrease of pressure is caused by change in fluid volume in blade channel. And lastly, the water heat are converted into high velocity jet by the impulse turbine, which then impact the bucket at a single point. So as we can see, for the left is the impulse, and for the right is the reaction turbine. So there is two different. There is about 6 different between these two, such as energy for impulse, all the energy will be converted into kinetic energy by another, and for reaction turbine only some amount of energy will be converted into kinetic energy. And next, water discharge need by impulse turbine is low, and for the other one is medium and high. And water flow tangential reaction to the turbine wheel for impulse, and for the reaction is radial and axial. And for efficiency, impulse has more hydraulic efficiency, while the reaction turbine have relative less efficiency. For the water head operate, impulse turbine is high, meanwhile the reaction turbine is medium and low. And that's then, for example, for the turbine is impulse turbine is Pelton turbine, this experiment, and the reaction turbine is the Francis and Kaplan turbine. Last but not least, I will tell you about the Pelton turbine. Pelton turbine is tangential flow impulse turbine, in which the pressure flow of the water is converted into kinetic energy to form high-speed water jet, and this jet strapped to the wheel tangential to make it rotated is also called as Pelton wheel. And the turbine which spin in both radial and axial direction. Efficient hydraulic performance may be improved, and lastly, the shape of the jet impact The turbine bucket determines the performance of turbine and it is dependent on the nozzle shape. Okay, that's all for me. Thank you. Assalamualaikum.
Assalamualaikum. My name is Hazika Najiha binti Muhammad Kamal Arifin, MA 18277, and I will present the methodology and procedure in experiment 5. So, water jets impinge tangentially on the fastened buckets in these hydraulic turbines. The power output provided by the pelton turbine is calculated in this experiment using data from the pressure sensor, flow sensor and tachometer. The method is to supply torque by conducting or exerting force on the buckets of the pelton wheel because it rotates. Next, we go to experiment equipment. Several important components are used in the pelton turbine experiment, including the pelton turbine, hydraulic table, data measurement and acquisition, and tachometer. The water pipe is tightly connected and a valve is fitted to control the main flow. The pelton wheel includes a spring balance, pressure sensor, flow sensor, tachometer, spear controller, nozzle, pelton wheel and brake adjustment. Lastly, we go to experiment procedure. First, the connection is made sure, tightly connected and no leakage. Number 2, emergency button is released. 3, the water is added in the hydraulic bench to full tank to supply water during the experiment. 4, the hydraulic bench is turned on and the valve is in vertical orientation. 5, the spear controller is released to control or fix the volume, flow rate and flow velocity. 6, switch on the main switch and measuring tank level are measured after 60 seconds and the data are being recorded. 7, observe the flow sensor, pressure sensor and tachometer and record the data collected. And last, the valve is turned to horizontal and the main switch is switched off after experiment is done. That's all from me. Thank you.
Assalamualaikum and good day to Dr. Fadzil. My name is Siti Rana binti Abdul Rahim, metric ID MA 18240. I will continue our presentation on chapter 4 where I will be focusing on the results graphs and discussion. For this chapter, it will cover turbine efficiency and also power curves. Turbine efficiency. For this experiment, the values for pressure, flow rate, rotation speed and also torque are provided. Therefore, the rated speed, output power, input power and also efficiency can be determined by doing a simple calculation by using this formula. These three figures show the relationship between rated speed and torque, efficiency with torque and rotational speed, as well as output and efficiency. From the table, with constant pressure, constant flow rate, the values of input power, as well as the decreasing of rotational speed, it is possible to prove that the higher the output power, the higher the efficiency of the turbine. However, the highest output power is obtained from the product of 0.625 Nm for torque and 67.7537 radian per second for radial speed. As the result, the turbine efficiency exceeds 100% as the output power becomes higher than the input power. Due to the conservation of energy, the efficiency cannot reach or exceed 100% because there will be a loss of energy in the system. Thus, the output power can never be higher than input power. Based on the line of this graph, the turbine efficiency increases as the rotational speed decreases. Because efficiency does not depend on speed, as it mainly depends on the torque. As illustrated in both graphs, torque plays a very important part in affecting the output power and turbine efficiency. Torque is the backbone for the efficiency of the pelton wheel turbine. And comparing both figures, since torque and speed are inversely proportional to each other by referring to this formula, and output power is directly proportional to torque, the torque at 647 RPM has to be reduced to obtain lower output power and to acquire efficiency below 100%. Therefore, it can be concluded that there is a slight deviation to the torque during the experiment which has caused an inaccurate data collection. Next is power curves. The values for rotational speed and output power are given to calculate the radial speed and also torque to plot and study the turbine power curves. The formula used are similar in the previous calculation. So this table shows the overall results for plotting the power curves for the turbine, which are represented in these two figures to illustrate the relationship between rotational speed with efficiency and output power, as well as output power against efficiency and torque. Comparing to the previous condition, the data displayed in these figures and also this table show the performance of the turbine at a lower constant flow rate, but at the same constant pressure, 0.2 bar, which produces a lower input power. The rotational speed decreases. Therefore, the calculated radial speed also decreases, while the calculated torque increases throughout the experiment. It is also clear that the output power is directly proportional to the efficiency because, as you can see from this table, when the output power increases up to this point, the efficiency also increases. But then when the output power starts decreasing, the efficiency also decreases. However, referring to this graph, at some point, although the torque is increasing, and we know that the torque is directly proportional to power, the output power and efficiency start reducing at some point. So we can conclude that this may be due to the very low rotational speeds. And from the provided data, the speed is reducing and is very low. Therefore, although the torque values are increasing, a very low rotation speed can also affect the performance of the turbine. So I think that's all from me. I will pass this presentation to my friend. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sulaiman Bazisha, ID MA19033, and today I would like to present about for the last part, conclusion. Throughout this experiment, constant pressure flow rate and input power as well as decreasing of rotational speed, it is possible to prove that the higher output power of turbine, the higher the efficiency. However, the highest output power is obtained from the product of 0.6250 Newton meter for torque and 67.7537 radian per second for radial speed. As a result, the turbine efficiency exceeds 100% as the output power becomes greater than the input power. Due to the conservation of energy, the efficiency cannot reach or exceed 100% because there will be a loss energy in the system. Thus, the output power can never be higher than the input power. The inconsistency of the result is caused by some factors such as human and environmental factors. The rotational speed decreases. Thus, the calculated radial speed also decreased while the calculated torque increased throughout the experiment. It is also clear that the output power is directly proportional to the efficiency. Thank you and Assalamualaikum.